So we have these 5 categories of structural particles: nonpolar molecules, polar molecules, ionic compounds, metals, and covalent network compounds. And in this class, you're expected to be able to classify a compound into one of those 5. And you need that to be able to figure out something else we're going to learn about today and then again on Monday. Okay? In general, I've ranked these classifications of materials, ranked by their structural particles. They're it's like a brick that's used to build a house. The brick is the structural particle, the house is the structure itself. Okay? But I've ranked these according to how they fit together by melting and boiling point. So basically, down here you have the highest melting and boiling point substances, and up here you have the lowest melting and boiling point substances. So this is melting and boiling temperature. Now, since it's important that you be able to look at a formula and figure out what category they fit into, and it's also important that you know how they rank next to each other, I want to give you a few notes to help you clue in, some reminder notes. These are things you probably should already know. We've gone over it before. A lot of it's been done in previous units. But I'm going to give you some reminders about how you look at formulas and determine whether they fit one of these categories. Okay? Now, nonpolar molecules are always made of all nonmetals. So all the elements in a nonpolar molecule will be all nonmetals.
Nonpolar molecule.
Polar molecules also are made of all nonmetals. And the way you tell the difference between the two, polar molecules have to meet those 2 conditions we just talked about. We just spent time going over and you just took a quiz on. They have to have 1, polar bonds, and 2, they have to have an uneven arrangement of those bonds. So then the nonmetal, or the nonpolar molecules, just simply don't meet both conditions. To be polar. Now there's another category down here at the bottom.
What does that say on the side?
Where?
Oh, never mind. Melting and boiling.
There's another category down here of compounds that are made of all nonmetals. The covalent network compounds. And when you look at the formula, the way that we're going to be able to tell when you have a covalent network compound is that you have a variable subscript, usually an X. So we have a subscript that is a variable. An example, SiO2 followed by a subscript X. Okay? So that X is a subscript, that's a variable.
Example, SiO2.
Yep.
Dash 2. Or
SiO2, and I put all that in the parentheses, put an X outside of it.
that's an X. Oh, that's an
That's an X on the outside.
Two.
All right. The way you look at a formula for an ionic compound to tell that it's ionic is that it's going to be made of one, it's going to have one of two things in there to tell you it's ionic. One of those things is going to be a metal bonded with a non-metal.
Look at this eye on it.
Mm-hmm. And the other thing that you're going to have in an ionic compound formula that will tell you that it's ionic is if it has a polyatomic ion in the formula.
I already have this.
Yes, you do. We're reviewing. I said this part over here I said was review. Some of this was review. Some of it's a little bit new.
Mr. Taylor,
Mm-hmm.
I got pulled over yesterday.
By a law enforcement officer.
Me and Tyler both got pulled over at the same time.
You know, like Stanley.
Wow.
Stanley.
He had blue lights on his tag, and I didn't have the tag.
Okay. Now, you should know how to tell when you have a metal.
It's all known
What? Metals have what kind of
All non-metals.
non-metals?
All non-metals?
All non-metals.
No, metals are just metals.
Yeah.
Like iron.
Yeah, like iron. Okay? Metals,
Metals are all non-metals.
listen,
Defeats the purpose.
listen, that's true. If it's if the element symbol and it's just an element symbol is it's on somewhere on this side of that dark stair step there on the periodic table. If it's somewhere over here, that's a metal.
Oh, no.
Left side's metals. Okay? All right. So it's on the left side.
The metal. Oh, yeah, left side of stairs.
Okay, left side of the stairs. We can put it that way. Left side of the stairs. Okay?
Let's go upstairs now. 68.
So here's what you need to memorize if my going over it with you, and taking notes has not committed it to your memory. What you need to do, what you need to memorize
Study.
is the fact that these categories fit in this order, from lowest boiling and melting point to highest boiling and melting point. You need to know how to recognize those. Almost all of these are review. This is a little bit new. That's not really new. But these categories are all review. The fact that we figure out it's a covalent network compound, putting a subscript X, that's a little bit new, yes.
Why did you put the highest on the bottom and the lowest on the top? It's confusing.
Just the way that it's listed. You know, I don't know. It's the way I think about it. Okay? Now, and you need to be able to recognize those formulas and figure out which category they fit into. And then you need to be able to rank chemicals by their formula according to which one is likely to have the highest boiling point to the lowest boiling point, or highest freezing point to the lowest freezing point. Okay?
That's hard.
Can they fit into one category?
I won't give you one that would. If I give you a list of compounds by formula, should be relatively easy to categorize. Okay, I'm not going to throw things at you that are really, really hard to figure out, or should be hard to figure out if you've been following along and working hard in this class. Okay? Now, listen please. We talked already about what it is that causes polar molecules to stick together. Polar molecule is a single structure, a molecule that has partial negative and partial positive sections. We talked already about what ionic compounds, how they stick together. Ions that have positive charge, completely positive, not something that has a little bit of positive, a little bit of negative, but completely positive, and an ion that's completely negative will be attracted together by their opposite charges. We talked yesterday about why metals stick together. Can anybody recall and tell me what the name of the theory is
Well, chalk.
that causes metals to stick together?
Theoretical what?
The electron C model. We went over it in class on what causes metals to stick together. The electrons provide a kind of glue that holds the metal atoms, which are something like atoms, something like ions, holds it all together. Covalent network compounds are held together by covalent bonds. Okay? We need to look a little bit, in the time we have remaining,
6 minutes.
about what it is that gets non-polar molecules to stick together. Okay? And these are called London forces.
Yeah, we talked about that.
We're going to talk about it some more, so keep taking notes, please. London forces.
London Bridge.